right, well, good morning, everyone, and thank you so much for joining us today. We are thrilled to have you here. This is our second annual user conference. We had our first last year in San Francisco with about half as many people, and it was only one day, and the feedback was the audience just wanted more product demos, more roadmap sessions, more customer testimonials, and so we've expanded it to 2 days. We've got a great lineup. We've invested a lot in the content, and we really want this to be the most impactful technology event that you attend this year. So my name's Katz, and I started the company ClickHouse Inc. alongside Alexey Milovidov, the creator and chief technology officer of ClickHouse, and Yuri Israelevsky, an executive you'll be hearing from, who I had met over 10 years ago when he was running platform engineering at Netflix, and he then subsequently went on to Google. And so I'm going to talk a bit about kind of framing the next few days and some of the themes that we're seeing in the industry. But this is just a representative sampling of some of the people who are in the room today and the companies that they represent. And if you were with us a year ago, maybe a show of hands for those of you who were with us a year ago. Well, thank you so much. So obviously, it must have been a successful event for you to come back and join us. But this slide would have been largely dominated by leading AI companies, venture-backed startups, and you can see this evolution that we've now experienced. You see a lot of native San Francisco, Bay Area-based companies that develop products that I use every day in my consumer life, companies like DoorDash and Instacart and Uber. But now you start to see, more traditional companies, manufacturing companies like Toyota and Rivian and Texas Instruments, and you start to see financial services companies like JP Morgan, Bank of America, Wells Fargo, Visa, American Express. And so there's a shift that's occurring in the industry. We're all seeing it every single day. And while it typically starts with venture-backed technology startups, and there's no better place than here, the heart of Silicon Valley in San Francisco, it's quickly moving upmarket and into the enterprise. And so we welcome these larger, more traditional companies to sit alongside these digital native startups. We acknowledge that we exist solely because we're part of a much broader technology ecosystem. And these partners of ours have made it possible for everyone to be here today. And so I'd like to recognize the 3 large hyperscalers that we run on. We initially launched our cloud service in 2002 on AWS. We then subsequently deployed it on Google Cloud and then on Microsoft Azure. And I think today we are deployed in over 30 different regions around the world. Over half of our customers are outside of the United States. So what we're going to do is take the content that we present today and tomorrow, and we're going to take it onto the road. And so for your colleagues that are in Singapore or Sydney or Tokyo or London or Amsterdam, we're going to get in front of them over the course of this year to present the same content and hear what they need us to build to support their initiatives. But then you go down to the other technology providers that you see here. DBT Labs, Tristan is going to be joining us tomorrow alongside Guillermo from Vercel, which I'm really excited by, and Lucas from Weights and Biases. Those 3 entrepreneurs are going to be joining us in person here, so I would encourage you to come back. And then later this afternoon, I'm going to be doing a fireside chat with the founder and CEO of Sierra, the chairman of OpenAI, Brett Taylor. So I would also encourage you to stick around this afternoon because I think that's going to be a really interesting session. I've known Brett for a long time, and I think he's widely recognized as one of the most successful entrepreneurs in our industry. So DBT, Hex, Temporal, MinIO, and Sigma, Data Hub, Estuary, 514, Odigos, Run Reveal, and Supermetal. We are very grateful for your sponsorship today and tomorrow and your partnership. So none of this would be possible if it wasn't for my co-founder, Alexey Milovidov, who I'm going to hand this over to in a minute, who came up with the concept of ClickHouse. It's short for Clickstream Data Warehouse. Alexey had to solve a very specific problem around web analytics, how to quickly analyze billions, if not trillions, of rows in a single table and support hundreds of thousands of concurrent users and do so in a very cost-efficient way, as you've got petabytes of data streaming in and you've got petabytes of historical data that you need to store and analyze efficiently. And that was 17 years ago in 2009. Alexey then had the bold decision to open source ClickHouse in 2016, in June of 2016. So next month, we're going to celebrate the 10-year anniversary of ClickHouse being open sourced. And that's when I first discovered ClickHouse, when I started seeing companies like Uber, Deutsche Bank, Microsoft, Disney, Comcast adopt this technology for a wide array of use cases. And so then 5 years later, I embarked on a journey to kind of unleash the potential of this technology and start a company around it. So we started the company roughly 5 years ago. It's a venture-backed startup. We launched our cloud product, ClickHouse Cloud, as I mentioned, in December of 2022. Fast forward 3.5 years later, and the evidence is in the room of the adoption of the technology. I haven't seen anything like it in my career. I've been in enterprise software for 30 years, and I've never seen a community grow this quickly around a technology as powerful as ClickHouse. We've had numerous funding rounds. You can see that here. I'm sure there's a lot of portfolio companies of these investors in the room today. So we've got the right financial backing to make sure that we're here for the long run. And we're also a very efficient company. We think very deeply about how we spend money. We've joined forces with other companies. I'm going to talk about the technology teams that we've brought on board and acquired, and how that's really expanding how you can think about the surface area that ClickHouse covers. And then just this morning, we announced some pretty significant milestones for the company. We announced that we passed 4,000 customers using our managed service, ClickHouse Cloud. And we added 1,000 in the last quarter alone, which is pretty staggering. It took us basically 3 years to get to 3,000, and in 3 months, we added an incremental 1,000. And so for those of us that have been in the industry for a while, you can start to see these network effects that take hold, that people that used us at Anthropic or OpenAI or Vercel, they go and start a company and they bring us with them. And so we're seeing this massive growth in customer adoption. And why are we seeing this, right? We're seeing this because people have the need in this new AI agentic era for technology that can handle massive concurrency at a very low price while delivering extremely low latency experiences for your customers, whether they're internal users or external users. And there's frankly no other database in the world that can satisfy those requirements as well as ClickHouse. And then the core team that we brought on board originally when we started the company, had the ability to redesign the table engine itself and develop what we call shared merge tree to enable the separation of compute and storage, and you'll hear more about that. Whereas if you're using open source ClickHouse, maybe just a show of hands, who here is using open source ClickHouse in kind of a self-managed, shared nothing architecture? Okay, and then, so that's almost half the room. And then who here is using ClickHouse Cloud, the serverless offering with the separation of compute and storage? Okay, so it's pretty evenly split, which is great to see. And one of the most, I think, powerful aspects of our company is of these 4,000 companies that are unique companies that are using ClickHouse Cloud, the number one source of migrations, I thought it was going to be, Redshift, BigQuery, Snowflake, Elastic, you name it. The number one source of migrations are open source users migrating from a self-managed architecture to ClickHouse Cloud because of the benefits like auto-scaling and idling, and you're going to hear more about that over the course of the next few days. But I think this is probably one of the more powerful images in this presentation, which is the leading AI companies, because the demands that they're facing are unlike anything we've seen in the industry in terms of how agents are hammering these systems, the volume of activity, the query patterns that were originally, legacy data warehouse technologies, like some of the ones I mentioned, were designed for human behavioral patterns, things that were highly predictable, things that were human-oriented. Now, agents have an entirely different query pattern, and so these companies are needing to adopt technologies like ClickHouse to support that. Lovable, 3 million apps, adding 25,000 a day. Anthropic, who's using us for observability, their environment has 10x'd in the last 4 months alone. Our spend with Anthropic has 10x'd in the last 4 months alone, which is kind of an interesting stat. I asked the team, back in December, I said, are we adopting these coding agents quickly enough? I want to be on the forefront of the industry in terms of how we're developing our software products. And it was told to me that we spent, in the month of December, $20,000 on Claude. And I thought, I don't think that's enough. And so fast forward 4 months later, I asked our CFO, I said, how much did we spend in May with Anthropic? Who can guess? $300,000. So I think I may have over-rotated on my messaging to adopt these coding agents. But you can see why companies like Anthropic and OpenAI are experiencing such remarkable growth. And so I'm going to hand it over to Alexey to talk about the open source development over the last decade, where he's taking it, and then I will come back on shortly.
So we have 10 years of open source. Actually, almost 10 years. We will celebrate this year on June 15th. And it's interesting to see how different people measure the growth of the company, measure the growth of the product. Some people measure it with ARR, the number of paying customers. Some people measure it by the number of GitHub stars. But who cares about the number of GitHub stars? I don't. I measure the growth on the number of contributors. People who sent a feature or sent a bug report or changed something in the documentation, who put some effort into ClickHouse development. And now we have 2,500, almost 2,500 people contributed to ClickHouse. And maybe there are some contributors in this audience. If there are not many, I would not be worried, because you still have time. You still have time to open your laptop after this presentation, find the ClickHouse source code, and implement a new feature. You don't even have to code it by hand. You can use coding models. It's totally OK. But also, it's a big question. What does it take to support all this growth? We have to review. We have to merge all these pull requests. We have to ensure that ClickHouse remains high quality, trustworthy, reliable database. And it takes a lot of efforts. And we have to invest a lot in our engineering teams. We see this chart about the growth of the company, and we can say about the numbers, it's actually boring numbers like 500 employees and more than 70 people working on the ClickHouse server, C++ code base alone. But for many companies, the growth could be a sign of losing focus, a sign of erosion of this focus, but not for ClickHouse. We have to invest in the core team, and we have to maintain this focus to support our growth. And let's take a look what have we done during these years, these 10 years of open source. A lot of interesting features. It was difficult to decide which feature to put on this slide, which feature to omit, because we have so many interesting features. And many of you are wondering what is my favorite feature. And would you try to guess? What? Just a few guesses. What is my favorite feature in ClickHouse? JSON, joins, iceberg support. Maybe I will disappoint you just a little, but my favorite feature is ClickHouse Cloud, because it makes ClickHouse accessible for many, many companies like you. It makes everything available out of the box. You just start using it, and it gives you all you need. But also, let's pay attention to these features. Yeah, you guessed it correctly. Iceberg. JSON data type, vector search, full text index. And I would like to mention that many of these features, like full text index, joins optimizations, we developed this after the previous conference, the last year. And tomorrow, I would like to invite you, I will invite you to see my presentation, my keynote about what does it take to build a great database, ClickHouse. So, welcome to Open House Conference, and now back to Aaron.
Thanks, Alexey. You know, one of the wonderful things about open source is the community adoption and how it basically spawns the emergence of new companies. You know, I started in open source almost 30 years ago at Sun Microsystems when I was working on the Java station. And then many of us spent time at the company behind Elasticsearch. And so we've seen this emerge in these types of companies that are formed on the backs of these open source technologies. It gives us really a front row seat to pick and choose who we want to join forces with. And you know, over the last 4.5 years, we've made 6 different acquisitions to really broaden how people are using ClickHouse, or to make one of our use cases like observability or data warehousing or real-time analytics more feature complete. Some of these are proprietary and some of these are open source. And you know, back in 2022, we knew that we needed a SQL console so that you could explore your data in a ClickHouse Cloud service. And so we met the team from Archetype and joined forces with them. There was then an open source project that was formed out of Asia by a developer named Oxton for in-memory embedded ClickHouse. And that was CHDB that we acquired 2 years later. We then saw Postgres emerge as one of the leading sources of migrations. I talked about open source migrations, but actually Postgres is number 2, where obviously it's the most popular database in the world. It's an obvious choice to get started on, but as many of us have experienced, Postgres doesn't necessarily scale when it comes to analytical workloads, when you even get into terabytes of data. And so we met the team from PeerDB. You'll be hearing from Sai and Kaushik later today. They had a very popular open source CDC protocol, change data capture, on how to get data from a transactional database and replicate that or migrate that into an analytical database like ClickHouse. And that has become ClickPipes. You're going to hear more about that. Observability, which is the first use case that I experienced ClickHouse in the context of, spawned a lot of popular visualization layers for this next generation of AI native observability workloads. And so we met Mike Shee and Warren and the team and acquired HyperDX, which is now our ClickHouse native turnkey observability solution. We then saw the launch of ChatGPT and the emergence of these chat interfaces and the ability to interact with your data through just a natural language prompt. And we met the team, Danny specifically, behind LibreChat, the most popular open source chat interface in the world. And we convinced him that he should join our company because we have such a better together story. And then we saw the emergence of this new category, which we kind of broadly call LLM observability. And there are a number of companies in this category. I'm sure you know many of them. Most of them are built on ClickHouse. And we met the team behind Langfuse. And I'm about to introduce Mark, and I see Clemens in the audience, and their third co-founder, Max. And they're in Berlin, Germany. And we met them last fall. We just fell in love with this team. And we were able to convince them that instead of raising venture capital, they should join our company, and they fortunately made that decision to do so. So we've also joined forces with Langfuse, and I'm thrilled to introduce you to the co-founder and CEO of Langfuse, direct from Berlin, Mark Klingen.
Good morning, everyone. Super happy to be here. I'll stay here. I'm Mark, co-founder of Langfuse, and I mean, building agents has never been about calling the model, but rather about the process of actually measuring how it works, how to improve it. And before I bore you with more slides, I thought I'll bring a quick demo for everyone who hasn't seen the product before. This will be fast, so buckle up. We have an example project in our documentation where we just answer questions about Langfuse. So if you have questions, you can just ask, and it'll basically search through all of the documentation to provide an answer. But if you don't like it, you can also provide user feedback. And this is, for example, something that then in the end ends up in Langfuse as an evaluator. If we submit the feedback, we can then open Langfuse and sign in with ClickHouse Cloud if you don't want to use another SSO IDP. And now this might look like a traditional observability platform. If we then click into a trace to really see what is going on with this request that we just made, we see a couple of things that are fairly different from traditional observability. So for example, cost tracking is really important to understand whether a specific agent action is costly or whether make a profit on a user. On the left side, we can see step-by-step what happened within the agent interaction. And at the bottom, you see this graph representation, because often these agents might make like 1,000 different tool requests. At the top, all of these evaluation metrics are really interesting, because with agents at runtime, they might do like a 200 OK, but it actually doesn't make any sense. So you really need like LLMs to grade the output, collect user feedback, all of these things. Or you need to bring in experts to label data, so you can have domain experts to add additional annotations to the product. And we also have like a queuing product to manage this workload. When then, like for example, a new model comes out and you want to interactively try it, there is a playground in LangFuse to test things side by side, more interactively, intuitively, and we'll touch on more structured experiments in a bit. Then one common use case is to basically filter down everything that happened with the agent based on these evals. So for example, look at all of the interactions where users complained. So for example, where user feedback equals 0. I touched on these kind of like evaluators. So LangFuse can task LLMs to grade these outputs and orchestrate all of these pipelines. And offline, we can use data sets and experiments to test whether things improve or regress. So for example, here we have a data set with all of the sorts of different questions we might want to improve our like LangFuse question answer bot on. And now we can run experiments, for example, in notebooks or in CI/CD, and then compare these results side by side. So this is now like a drill down of what happens step by step for these example questions. We can set one as a baseline, see the comparison to really interactively control for changes in how they improve or regress. And all of this is backed by tracing again, because this is not an MLOps problem, but really you want to see what happens within an agent. We integrate with the whole ecosystem via OpenTelemetry. LangFuse is open source. You can self-host it on any hyperscaler. We have Terraform modules in the Helm chart for Kubernetes. And in the end, this is the whole deployment footprint. It's very, very stable. And ClickHouse is the core data source for all things like observability in LangFuse. LangFuse is very much agent native. So we have like a public API and CLI and some skills. So for example, this is me asking Codex to chew 9 minutes on the data in this example project to give me suggestions of how to improve this agent. And in the end, it concluded that this agent's always directly moving into like an answering mode to help answer questions, but sometimes it should just also ask some like follow-up questions. Overall, I'm super excited to be here, because we get to work with so many amazing companies that build the future, such as like Adobe, Intuit, Merck. And how did we got here? Basically, my co-founders and I did YC back in 2023 when ChatGPT was just released, building agentic experiences, but really realizing that building a demo is easy, but productionizing is really hard. Thus, we built our own tooling for it, because traditional observability and ML ops tooling didn't really cut it for us. We then open sourced and launched it on Hacker News and Product Hunt that same summer. Back then, all of these applications were simple workflows, so just like call a model, process directly the response. And then as over the course of 2023, 2024, we matured to more like agentic experiences. Also, LangFuse matured into more evaluation and collaborative prompt management tooling. And then these things grew a lot. So some customers scaled out and saw a lot of production workloads. And we got pressure. And as Aaron mentioned, there's like a lot of movement from Postgres to ClickHouse. There was the same case for us, where when Max and I built the initial version of LangFuse, I think it was like in a week. Obviously, it was like a single container and a Postgres database. But then as we matured, we needed to like put it onto like a better foundation and switch to ClickHouse. And now as like we go from agents, multi-agents to coding agents, and really like volume really increased. We are very happy to be part of ClickHouse since early this year. More on this now, because LangFuse is really like a ideal ClickHouse-shaped workload. So the decision to go from Postgres to ClickHouse was an easy one, because we have like a large event volume, like high cardinality of attributes, because you don't know what you want to query by when you read the data, when you ingest it. And you really want to interactively explore it or have agents interactively explore it. And all of this is real time. So we couldn't wait for like a database that's more batch-oriented. generally the story of why I was excited together with my co-founders to join ClickHouse was mostly because Langfuse was, at that time, the most popular open source project in the space, like seeing a lot of adoption, for example, 19 of the Fortune 50 adopting Langfuse, or 27,000 GitHub stars. Alexey doesn't like this metric. Maybe it's 59 million SDK installs. So we just tracked the open source and really saw it growing. And at the same time, also our cloud really grew, and we built out everything on OpenTelemetry to be really open and interact with the ecosystem and build more enterprise grade. But one thing that we were lacking was like really being tightly integrated with the database team to optimize the database for the workload and the workload for the database, and work with this global go-to-market team as well, because Langfuse is really like a global product. And yes, we have a strong team in Europe and here in SF, but I'm really excited to now collaborate with teams like globally to support customers where they are and give them the deployment flexibility, for example, now also with like a more BOLC product. This was a lot for 5 minutes. If you want to learn more, later today in this hall, I do like a much longer live demo of what Langfuse can do. We'll have Sean and Manas from Intuit on stage to talk about their platform journey with Langfuse, because they use Langfuse across like dozens or hundreds of different AI projects. And I'll demo everything that's new with Langfuse. So we have lots of new exciting releases. And now over to Tanya.
All right. Thank you, Mark. This is exciting. So my name is Tanya Bragin. I lead product management and marketing at ClickHouse. And today I want to walk you through what we're seeing across the data teams that we talk to when it comes to how AI is changing the nature of their jobs. And I probably am not telling you anything new when I say that AI is changing the nature of all of our jobs. We just talked about coding agents. But for data teams, this shift is particularly dramatic. And in fact, what I'm hearing from a lot of teams is they're not necessarily concerned about availability of models at this point. The models have gotten very, very powerful. Or even the cost of tokens. It feels like, oh, like we can optimize that, it's still early. But it's really the data layer where everything is becoming bottlenecked. And there's a very simple reason for that. If you look at this picture, when it comes to various use cases, if you have a human analyst or a human user of a SaaS interface, they follow a fairly predictable pattern, and on the back end, the database workloads can be optimized. Once you introduce an agent in a mix, everything is completely different. Agents can generate queries much faster on the basis of a single prompt, and the reason for that is they need context, right? And they will query this in parallel as a human user is doing their work, or maybe even an autonomous agent on the behalf of that user is doing that work via a natural language prompt. So the database backend is now getting slammed by unpredictable queries at a much, much higher concurrency rates. That's really the reality. So all the data teams that we speak with, and this is across developers building applications and data engineers working with their internal stakeholders on next generation business analytics, and SREs and DevOps engineers working on how to apply AI to production operations, all of them are looking at their current data stacks and asking themselves a question. Are they AI ready? Are we AI ready on this layer? And the answer, unfortunately, depending on what you have in place, some of these legacy data platforms may not be AI ready, or just they were not even designed for this kind of workload. So let's take a look in more detail and more specifics. So first of all, developers building customer-facing applications are actually in the best, I would say, state here. They've already been dealing with internet-scale workloads, highly, highly concurrent. And because of the shift in what these applications look like, being much more data-driven, interactive, kind of intensive applications, they've already been, as Aaron mentioned, moving from only having, like, say, a homogeneous general-purpose transactional database to also having other databases, such as, for example, ClickHouse for real-time analytics. And so they have a number of databases. They also tend to move very fast. If they need a database, they add it to the stack. If anything, we're seeing the need to combine them and unify them, and you'll see us doubling down on this use case. Because again, if you have a natural copilot, it doesn't really care which database you have. It's just going to throw unoptimized queries that it kind of brute force its way through. So there's definitely things that we have to solve, right? It's not an unsolved challenge, but I would say that developers are in the best position here, powered by the innovation that we've already seen in this space. For data engineers, again, depends on the stack, but the challenge is that the traditional data warehousing systems and data science systems have been designed either for kind of batch analytics, you run a workload overnight, and that's okay because it's maybe like you're training a model and the real-time kind of aspect of it is not so important. Or again, a data warehouse is being used by a specific analyst, and again, the results can be brought back to other stakeholders with some delay. And it was acceptable to have kind of this batch latency, and I would say relatively limited concurrency, because it was limited by the number of people that had the SQL skills to go and kind of analyze this data. And again, this is internal applications, not customer-facing internet scale. But this is changing, right? Because now, presumably, any person inside a company can just ask a question of a data warehouse in natural language, and why not? You want to democratize this data. You want to unlock the possibility of the business moving faster and being data-driven. Why wouldn't you want that? But your existing systems, again, the data layer may not support that. That's kind of what we're hearing, and this is the next challenge for these teams. And finally, for observability, the size of the workload is really the challenge here. Machines generate data at a huge scale. It is not a secret that all of us actually don't even really store this data. We aggregate, we summarize, we TTL it out. It's maybe in the best case in some sort of Glacier store. But again, for AI observability, if we're going to use this moniker, you need data and context, and AI needs access to a lot more history, a lot more fine-grained signals to help you, for instance, do detailed root cause analytics, or ideally even just get ahead of the problem and kind of bring you insights as to what in your environment may be unoptimized or is starting to run in a way that's not ideal, and you should get ahead of the problem. So again, there's a lot of promise in this technology, but the bottleneck is the data layer. Now, the good news is that if you look at these requirements, just kind of to collapse them all, real-time responsiveness, massive concurrency, cost efficiency at scale, there are answers to some of them in what we've already been talking about. As I mentioned, customer-facing workloads and the data stores supporting that are in the best shape, and potentially we can start applying that to agent-facing workloads in other contexts. That's exactly where ClickHouse gets brought in and augments or replaces other systems in place. And in fact, there is a benchmark that's been very popular. We published it shortly after we started the company, called ClickBench, that invites not only ClickHouse, but other technologies to compare themselves on this type of data set, a data set that is geared toward answering questions in real time and kind of like having that sub-second, millisecond level performance. But the challenge in the AI era is it's not enough just to have the performance. Again, the number of queries that's being issued is growing dramatically, and it's actually cost performance that's important. It's the cost of these queries that's becoming a concern. Can I really afford this at the database layer? So this is why we're announcing availability of CostBench. This is an open benchmark that looks not only at performance for AI-ready workloads, but also intersects it with a standardized model to assess that again against the billing model of the vendor or a technology provider. And this cost performance metric is the important one to look at going forward, because it really answers the question of not only just like, can I even execute this, but can I execute it in a way that's efficient for my business and that supports the budget for this initiative. So different data sets are supported. There's an open site, ClickHouse.com benchmark, that you can take a look. And again, cost savings can be dramatic. This could be the difference between being able to adopt AI at the scale of your organization or not. But enough from me. Let's hear from one of our users. So we have a senior leader from Visa, Rafiq, that is ready to come join us on stage and talk about what they're doing at Visa scale, again, highly regulated environment, with doing exactly this, looking at how to adopt conversational business intelligence with ClickHouse Cloud and LibraChat. Rafiq, welcome on stage. Thank you so much.
A very good morning to all. And I hope everybody has had a wonderful start to the conference. And I'll also go on to assume that everybody in the room is a card holder, Visa or Amex. So thank you for being a very loyal customer for a long period of time. Today I'm here representing our acceptance solutions group and talk about how we've been on the journey of bringing conversational business intelligence at scale with ClickHouse Cloud and LibraChat. At Visa, we share a deep love for enterprise scale data analytics, and we've had a very strong partnership with ClickHouse over the last 1+ year to enable a vision as well as execution to achieve a strong data analytics platform that powers business insights that drive business outcomes. And we gained some initial momentum within Visa to first start our journey with the ClickHouse on-prem solution with the open source version. And we've been successfully able to migrate terabyte scale of data for application logging from Splunk to ClickHouse. So that's a very successful execution model. Now we are moving beyond that and moving the needle on innovating with key analytics capabilities to bring LibreChat as a conversational AI intelligence layer on top of our business data to drive business outcomes. All of this with a very highly performant data stack while respecting the key security controls and governance principles within the Visa ecosystem. Today specifically, I'll focus on one of those adoption scenarios for authorized .NET payments platform. This is our payment solution for small and medium-sized enterprises that enable transactions with the Visa payment gateways. The numbers here speak to the volume, but they hide a story. For example, we process over 2 million events for transact authorization, and we need to analyze these. We have over 500K events of raw transactions across a huge corpus of data, about 40 petabytes, and that scales day to day. The data is fuel analogy really fits for SMB and enterprise level data because the data is very diverse across hundreds of tables in a multi-database topology, and the databases scale with terabytes of volume accumulating daily. The analyses are key because we have to process millions of rows of data to extract intelligence-based queries. Also, we have a strong bias for freshness of the data because transactions are made in real time and we need to extract value. The key signals that underlie the platform are across multiple modalities, entities, and complex relationships. For example, the merchants that transact on the platform, the gateways that enable payments across merchants, the usage, the APIs, segmentation of this data, how we can recommend usage of multiple features in our product, and you can draw and extend this analogy. And then this applies to a variety of users who would like to extrapolate and use this data, starting from internal product teams that have to understand what these signals mean and translate that into requirements, executives who look for key business metrics and results, and our own product to enhance capabilities and bring insights into our product features. So one long-standing challenge we've had is delays that accrued with bringing analytics engine, because we've had suboptimal implementation with processing large amounts of data, therefore leading to multiple days in achieving daily level reports or weekly or monthly. So therefore, that means we have delays in extracting immediate business value. And that's where we've challenged ourselves to build a real-time opportunistic platform that will allow us to extract the business value and drive business outcomes by modernizing our data analytics stack, fully native to cloud. Why ClickHouse Cloud has been a best fit solution is because now it completely offloads our management of the scale, because we can then bring infrastructure with very less movement and friction while focusing on business outcomes. It also gives us granular control of storage and compute cost, as well as atomically size our unit cost based on the scale and demand. ClickHouse also excels exceptionally well with flat table scans and hundreds of columns of data attached to it. It's also enterprise ready for BI integrations that are very key capabilities, and also provides state-of-the-art encryption and CMEK capabilities. The compression ratios also serve really well for storage, and we have a very vibrant community of customers and developers that accrue to have a very solid foundation. So coming to the solution itself, what we've built is taken LibreChat as a conversational AI interface with remotely hosted ClickHouse MCP server that can then interoperate with our ClickHouse database. And basically, evenly distribute the knowledge across all users. It doesn't have to be a seasoned SQL user or a very heavy SQL database engineer, but evenly distribute the knowledge that you can start working in natural language to extract the same level of intelligence. The complexity is completely hidden out of the way, and we also achieve very great performance. So overall, what we can achieve is sub-second queries over millions of rows of data. And you can see we've been able to successfully do our revenue analyses with 50x incremental rates, as well as approval rate analyses at 68x factor of improvement. The data insights problem has now been squashed into milliseconds from multi-day. As you can see, scenarios that encompass, these are just a few limited ones, but revenue by region, by quarter, slice and dice that data, approval rates by different card types, merchants, merchant risk analyses. A key thing here is to note how Visa achieves this in a secure manner. So the key principles of Visa data compliance and governance still are applicable. We start from raw SQL data and encrypt the files at transit, and then also move this data into raw, unstructured data store in S3. We also then enable VPC private link connectivity to build our custom ETL pipeline to migrate the S3 data into ClickHouse storage. Overall, what we'll then be able to achieve is have freshness of the data with governed access, with federated user access controls to access this data, which is ready for enterprise scale. I'll bring back the same analogy to just capture how user per week amount of effort has been now reduced to near zero or real time. Overall, what that drives is business outcomes in order to uplift the merchant revenue rates, identify and mitigate any revenue loss signals, and overall drive revenue across the product, company, and partners, and also save or enable users to reclaim valuable time because everything is now available at the fingertips in a natural language scenario. I'll now proceed into a quick demo, a demo role that will demonstrate how, with a fictitious merchant, but really representative of the enterprise scale data, to show how multiple scenarios are easily uplifted in a natural language query sense, going over the same scenarios that I highlighted here, from revenue to approval rates to identifying merchant risk in a quick run. So a familiar user interface here will welcome the user with single sign-on experience. The user then has access to the model catalog where you can pick your favorite LLM, log in, and start interacting with the data. The context is grounded to the user and their database, so you can examine the database as in what tables are really underlying the ClickHouse database and what materialized views you can use. And the user starts by querying for analysis of the revenue by quarter. Proceeds to then capture approval rates by multiple card types, by region, in real time. So there's a neat summary as well as a running dialogue where now the user can converse and have visualizations on top of this data, which we'll also see in a moment. But here I'm also highlighting how the user can supercharge this query as a materialized view, because it's just a snapshot update for new rows of data that are inserted. So this just demonstrates that the same exact query outperforms the previous query of raw table scan by 98%. And as we can see, for the materialized view analyses, we have a significant uplift in performance. Now, this particular experiment shows how the user is able to quickly transition into visualization of the data that he was examining so far in terms of real-time dashboards. And you can dynamically change these, interact with these, because picture speaks much more than raw summary. Now the user can continue with a slightly more advanced query, like, hey, give me analyses of merchants' transaction rates dropped beyond 20%, where the risk factor has also increased. It's a fairly complex query doing a multi-table join underneath across millions of rows of data. And you can see that in real time, we are able to extract a lot of value and then also extend that into visualization. And that should give you a very good idea of how this is super beneficial in terms of statistics, as well as using everything in real time. So hopefully, I was able to give you a front seat view of how we are driving this, and we'll continue to extend our partnership and build on top of our platform. Thank you.
Thank you so much, Rafiq. Thank you. Wow, this was inspiring. Thank you, Rafiq, for walking us through this. And again, hopefully this solidifies what we discussed earlier, that the battleground starts with the access to the data itself, the real-time access, and that really helps you drive business results. So are we done? This was pretty impressive. Are we done here, or do we need to build more? And the answer is, of course, there's always more, right? And so we're continuing to invest heavily in real-time analytics, data warehousing, observability. There are exciting product announcements coming right now here in this keynote following this. And it is my great pleasure to introduce Yuri Zvailevsky, who is the president of product and engineering, the co-founder of ClickHouse, to join us on stage to walk us through these announcements. Thank you, Yuri.
Thank you, Tanya. Good morning, everyone. So ClickHouse is a very versatile database. Supports all types of different workloads. So some operate better on normalized tables. For example, observability. You can just stuff everything into those giant tables and slice and dice through billions and trillions of rows in real time. It just works great. But some use cases, such as data warehousing, traditionally rely on joining facts and dimension tables. So join performance is really important. And of course, joins are notoriously hard to do in columnar databases when you're dealing with lots and lots of data that doesn't fit in memory. But we've put our best engineers on this task, and we've made a lot of progress. So over the last year, for example, our join performance improved 6x and improved 20 times over the last 4 years. Of course, it's not just about improving the performance. It's not just about the speed. Like Tanya talked about, cost efficiency is also very, very important. We talked about CostBench. So fun fact, it costs less than a penny to run the benchmark. So in addition to improvements in the joins, there is support for correlated subqueries that was launched in version 25.6. That was in last August. Many of you probably don't use correlated subquery. It's a fairly niche feature, but it is very, very important in a lot of benchmarks. Some BI tools use it. So able to support it as well. Join reordering, again, you don't have to worry about deciding which joint, how to organize the joins. The query engine does it for you automatically, and support for distributed joins. If you can distribute the workload, you can do it a lot faster. So now that is available as well. And of course, full text search. Again, data comes in all the different shapes and formats, and textual data is increasingly popular, both from humans and machine generated. Of course, we know that AI moves around a lot of markdown files, which is text. So we finally have proper support for full text search in ClickHouse. So for years, Elasticsearch has been the gold standard for full text search. And after we launched our implementation, we did some benchmarking. And for log analytics, we're actually 6 times faster than Elasticsearch. We're using 5 times less storage, again, thanks to ClickHouse's industry-leading compression rates. And we're also 4 times more cost efficient than Elasticsearch open source for full text search. So it's perhaps no surprise that a lot of large important customers such as Twilio, DoorDash, Lovable, and others are using full text search in production right now. So these are just some of the highlights about what happened, what was launched in the core database. And to get more details, please attend the data warehousing breakout session at 1 o'clock and the database core breakout at 3 p.m. Alexey is going to be part of one of the panels, so lots of great stuff to follow. Please don't miss it. Of course, AI workloads are collapsing the traditional divide between the transactional and analytical databases. So applications that once ran on predictable, hard-coded queries, right, that were hand-coded and generated specifically for the task, are now spread across agent-driven requests that need answers from both the analytical and the transactional stack in real time. And so to address that need, earlier this year, we announced the launch of private review for our own managed Postgres. And to tell us more about it, please welcome Sai Srirampur, who's the co-founder and CEO of PeerDB. Welcome, Sai.
Thank you, Yuri. Great to be here. Let's get started. Today, there are tens of thousands of companies like GitLab, Instacart, Cloudflare, and many AI-native companies who use Postgres and ClickHouse together to solve most of their data problems. Postgres powers transactions, and ClickHouse powers analytics. So basically, they are using the right tool for the right job. Looks like the industry has landed on the best-of-breed data stack, which is Postgres and ClickHouse. Let's also not forget that Postgres and ClickHouse evolved from the same open source ethos, which makes this synergy even more powerful. I just came to know prior to my talk that Postgres turned 30, and Aaron told that ClickHouse is going to turn 10 in the coming month. So both of these are incredibly battle-tested technologies. AI is making this best-of-breed data stack more critical than ever before. There has been an explosion with respect to data sizes and concurrency. Enterprise-grade reliability and security are more important than ever before. To handle this kind of scale and demanding requirements, it becomes very important that you build your data foundation on purpose-built technologies like Postgres and ClickHouse. Most applications start on Postgres. As they grow, they quickly realize that Postgres doesn't scale that well for analytics. Their dashboards start becoming slow, which is when they adopt ClickHouse, which sits side by side with Postgres, fully integrated with Postgres, and helps power blazing fast analytics. What we are seeing is something very interesting. This transition from Postgres to Postgres plus ClickHouse is happening at a much faster pace than ever before. We pulled up around 10 AI-native companies across thousands of companies who use Postgres and ClickHouse and saw that their data sizes grew by over 1,000% in the past 6 months. This is the kind of scale that we are talking about, and again, it emphasizes the importance of the best-of-breed data stack. Without further ado, I'm so excited to announce the launch of Postgres managed by ClickHouse. It is a fast, enterprise-grade Postgres that is natively integrated with ClickHouse. First, it comes with an enterprise-grade Postgres that is backed by local NVMe storage. This enables 2x to 10x performance for transactional use cases. And there are absolutely no compromises with respect to enterprise-grade reliability, security, and availability. Second, this Postgres is natively integrated with ClickHouse. Users get native CDC capabilities through which, within a few clicks, they can start syncing their Postgres data to ClickHouse and make it analytics ready. This is what eliminates all the external data pipelines and all the hassles associated to it. Next, it comes with this native Postgres extension called PG ClickHouse. This makes application development super easy. Developers can still use the same Postgres interface to power both transactions and analytics, but under the hood, use the right tool for the right job, Postgres for OLTP and ClickHouse for OLAP. So in a nutshell, the vision is to make it a no-brainer for developers to build their applications using both of these technologies together. Make all the workflows that integrate these two amazing technologies and build applications. So with that, the service has been in private preview for the past, few months. There has been tremendous demand. Like, there are thousands of customers who are in the wait list. We also have many customers who are running multi-terabyte production workloads on our Postgres service. I'd like to give a shout out to a few of our reference customers. First is Physical Intelligence. They are an AI native company who are bringing general purpose AI to the physical world. They migrated off RDS and are building their data foundation on Postgres and ClickHouse within ClickHouse Cloud. We also have other companies like Do Control, who is a cybersecurity company who migrated a fleet of their RDS and Aurora databases to Postgres on ClickHouse. You have Y Combinator companies like Enclose and Trainee, who are fast-growing AI-native companies, again, building their stack using ClickHouse Cloud. You also have enterprise companies like Quinto Andar. They are a very well-known real estate platform in the LATAM region, and they are building their customer data platform on ClickHouse Cloud using Postgres and ClickHouse, and they are using PG ClickHouse as a federated layer. So with that, I'd like to conclude my session by saying that we have a deeper dive that goes into the product features. You have internals of the product. We'll also have customer case studies, and we'll have an intimate Q&A where we'll take all your questions. So don't miss this one. It's going to be a lot of fun. Thank you so much.
At ClickHouse is very, very fast and very scalable. And of course, the Postgres that we launched is the fastest and the most scalable managed Postgres on the market. Now let's talk more about Alexey's favorite feature of ClickHouse, ClickHouse Cloud. So what you see on the graph here is the total data under management inside ClickHouse Cloud. So we first launched, as Aaron said, in December of 22. So we went from 0 3.5 years ago to over 100 petabytes of compressed data stored in ClickHouse Cloud as of the end of last month. Now it's even more. So given the typical compression rates of about 10 to 50x, for most customers, it means that we now have well over an exabyte of raw data uploaded into ClickHouse Cloud. So, and this isn't linear growth. This is exponential. Once a customer lands on ClickHouse, they tend to quickly shift more and more workloads and more use case onto ClickHouse. And that's why customers such as Cisco, Twilio, Capital One, Mercado Libre, Ramp, and many, many others trust to manage their production data in a scalable and cost-efficient way. And we're still just getting started. So Cisco Talos uses ClickHouse Cloud to manage around 2 petabytes of threat intelligence data. Very, very sensitive data, helping security researchers identify malware and support Cisco's security products. So Talos initially ran on self-managed open source ClickHouse. They considered all sorts of different vendors, and they eventually decided to migrate to ClickHouse Cloud. And in doing so, their total cost of ownership, TCO, actually decreased by 75%. Again, by moving from free open source self-managed ClickHouse to paid ClickHouse Cloud, they're spending only 1/4 of what they used to spend. So this is truly remarkable. And to tell us more about it, please welcome Sinay Gautam from Cisco. Welcome, Sinay.
All right, thanks for having me. My name is Sinay Gautam. I'm a software engineer with Cisco Talos. Today I'm going to be walking through how my team migrated a hash disposition table from self-managed ClickHouse to ClickHouse Cloud. I'll talk about what motivated our move, how we evaluated alternatives, and the technical journey of moving a 2 petabyte backend database into production with 0 downtime. So we'll proceed as follows. I'll talk a little bit about our context, what Cisco Talos does, and how my team supports their mission, our specific use case, and then I'll go over our technical journey in a little more detail, how we move from that self-managed cluster to ClickHouse Cloud. And then I'll wrap up with some of the results and the impact of our move. All right, so just to set the scene, Cisco Talos is one of the largest commercial threat intelligence providers in the world. Talos defends Cisco customers and raises awareness on evolving threats, partnering with industry and government organizations worldwide. Talos Intelligence Integrations powers Cisco security products, delivering automated protection and stronger defenses against a range of constantly evolving cyber threats. Our team provides a centralized data lake and associated enrichments that support this mission. One of our most prominent offerings is a reputation service that stores dispositions of individual file hashes collected from Cisco product telemetry. Our threat researchers use these data for guardrails that prevent false positive convictions of benign hashes, and our threat hunters use them to look for low prevalence hashes that might be signals for malware campaigns. In both cases, they, and by extension our customers, need fast, accurate answers. So, to give you a sense of the scale, we have about 1.9 trillion rows in production. We are currently ingesting about 25 billion rows daily, and right now we have around 190 terabytes of compressed data on disk with an uncompressed size of nearly 2 petabytes. So here's a stylized overview of what our architecture looked like before. Okay? The data originates in a Databricks table stored as Parquet files in our S3 environment. Our custom ingestion pipeline had an event-driven serverless architecture, and under our old retention policy, we kept about 1 petabyte of compressed replicated data on 32 high compute nodes with 7 EBS volumes attached to each. Okay, so it worked, but we started experiencing some challenges. So what were those challenges? First, operational burden. All right, we're a small team inside a threat research organization. Running a ClickHouse cluster of that scale meant that we were spending time on upgrades to the Kubernetes environment, backups, troubleshooting, instead of building new products for our threat researchers. Second, managing the requirements of SOC 2 compliance introduced an additional burden for our team that was already stretched thin. And third, our custom ingestion solution actually introduced architectural complexity that we wanted to simplify. So we looked at 3 options. Snowflake is a great analytics platform, but our query latency needs meant that we were going to have to go with a more complicated architecture than we would under ClickHouse. MongoDB's document model wasn't really a natural fit, and it wasn't cost-effective at the scale that we were operating. ClickHouse Cloud was the natural choice. We were familiar with the technology. The columnar storage model was a perfect fit for our hash lookup pattern. S3-backed storage reduced our storage costs. And finally, our conversations with ClickHouse Solutions Architect actually allowed us to implement a far simpler architecture than what we were doing with our on-prem or our self-managed solution. So here's the new architecture. We still have the Databricks Delta table as the source, but instead of our custom ingestion code, we use EventBridge to detect new objects as they arrive in S3, and then we route them to SQS queues and let ClickPipes handle all of the ingestion. So all of that custom code, all of that orchestration is gone. We use the shared merge tree engine with the S3-backed storage, and that's also fully managed by ClickHouse. The API Lambda function that we use to route queries to the back end is connected via AWS private link, so it doesn't go through the internet. And we were able to drastically simplify our back end by leveraging a smart partitioning strategy. So we were able to aggregate at query time rather than pre-aggregate in the cluster, and took a small hit to performance, but well within the SLA for our consumers, and again, drastically simplifying the architecture. So let me walk through the 4 phases of that migration. So the first was building reusable Terraform modules for the ClickHouse service, ClickPipes, and database resources. Then we deployed our dev and prod services. Phase 2 was the data pipeline, and this was the biggest lift. We had to backfill 12 months of historical data using sharded ClickPipes, And phase 3 was doing some shadow traffic validation, routing live production queries to both backends to do initial data validation and performance testing. Phase 4 was a comprehensive data validation at scale against the source data before final stakeholder sign-off and our cutover. So from an operational perspective, the results speak for themselves. We've been testing in production for the last month, and our SQS continuous ingestion pipeline has delivered roughly 3,000 files a day with 0 data loss and under 36 seconds of queue lag. So we're not waiting too long for the time between the file drops and when it's actually ingested into the ClickHouse Cloud database. When we compare API responses between the old and the new backend across over 1,000 hashes selected at random, our match rate was 100%, and all this validation was done with 0 consumer impact. The cost story is just as dramatic. As I mentioned earlier, our self-managed cluster posed several challenges. The query performance needs meant that we had to tie our ever-increasing storage needs to expensive compute nodes. Scaling up or down, depending on traffic, was a costly process that would mean service disruption for our consumers, and it meant ultimately that we had to over-provision. SOC 2 requirements added an additional burden where we basically had to be constantly vigilant about vulnerability management, further disrupting service. And our custom ingestion pipeline meant additional engineer hours for maintenance and incident response. Moving to ClickHouse Cloud has allowed us to dramatically reduce our TCO and save over 300 engineer hours a year that can be spent on building new products for our threat intelligence teams. All right, so I'd like to thank my team, Tiffany Dunbar, Christopher Evans, Zach Jones, Matt Slater, Doug Pichardo, and my manager, Chris Kopek, on this project. Thank you.
Amazing. Thank you. Amazing stuff. Thank you, Sinai. And it's also worth noting that Cisco decided to run their service in bring your own cloud model. So again, ClickHouse supports 3 different deployment models. There is the most familiar fully managed multi-tenant environment. There's the isolated deployment, and BYOC that runs inside customer's own account, which provides additional degree of security and control, and especially if you're dealing with security data, sometimes it makes more sense. Another way how we can support our customers is by expanding our global reach. So as Aaron mentioned, we're now running in over 30, in fact, 36 cloud regions across 3 different major geographies. 12 are running in the Americas, 12 in EMEA, Europe, Middle East, and Africa, and 12 in APAC. So whether your team is in San Francisco, or Frankfurt, or Singapore, or Sydney, or anywhere in the world, there is a ClickHouse region in your local territory, so you can satisfy your regulatory requirements and provide your customers with the low latency interactive experience that they want. Okay. And to ensure reliability in each region, we've built ClickHouse Cloud that uses cloud-native principles of redundancy and isolation to deploy distributed ClickHouse clusters across multiple availability zones. So it's a reliable service. But what happens when an entire cloud region goes down? It sounds a little far-fetched, but those things happen. Just in the last few months, heard about floods and earthquakes and power and network outages and geopolitical conflicts, and even sometimes rogue agents bringing down entire production deployments that can impact the whole region. So last year, a major financial institution here in the US came to us and they said, we'd love to use ClickHouse Cloud, but we have a very strict requirement. If a cloud region where we're running goes down, we have to stand up another cloud region within 15 minutes, and we cannot lose more than 1 minute of data in the meantime. So sounded like a good challenge. So we put our best engineers to task, and they came up with a service that, in fact, met those requirements. And as of April 1st, we've been running cross-regional active-passive replication. We've actually exceeded those requirements. Because it's a synchronous replication, we're losing 0 data in the process. And we can stand up the new region in just a few minutes. So as we're moving forward, we're definitely planning to make this feature available for all of you in the next few months. And over time, we're also looking to build active support as well. So when we first developed ClickHouse Cloud a few years ago, the main emphasis was on visual interactive experience, targeting humans. We have a nice UI console for admins to set up and manage their ClickHouse databases. There are visual interfaces for analysts and data scientists to edit queries and generate dashboards. Developers, of course, can access APIs and run Terraform scripts to build their applications. But now we live in the world of AI, and we have to satisfy new requirements. We now have an AI query builder that translates English into SQL. Very, very nice feature. Fortunately, I have not had to write SQL queries in over a year now. Great stuff. Managed MCP service that connect your ClickHouse data to your favorite LLM. But of course, in addition to human users, we now have another audience that we need to satisfy, which is agents. They don't care about consoles. They don't care about UI flows. Agents like Cloud Code, they operate on the command line interface. So to satisfy this requirement, we've actually launched ClickHouse CLI. And we're going to go into demo right now. So ClickHouse Cuddle is the standard command line interface for ClickHouse. So this is a demo where we ask Cloud Code to create a ClickHouse project for web analytics, and it's using ClickHouse Cuddle. So ClickHouse Cuddle is the standard CLI for ClickHouse that does everything. There's local setup, there's cloud management, there's schema management, you can generate queries, agent workflows, all of it. And it integrates with all of our managed products, ClickHouse Cloud, ClickPipes, ClickHouse Managed Postgres that you heard from Sai recently about. You can also install official ClickHouse skills into tools like Cloud Code, so an agent can use ClickHouse in the most efficient way. And again, this is the first milestone towards building a truly headless developer experience that's optimal for agentic workflows. And as you've seen, it took me longer to even talk through this demo. It took 50 seconds to go from making this request to Cloud Code to everything being up and running. This is really, really fast. So please check out ClickHouse Cuddle. So, of course, reliability, agentic support, all of those things are important, but at the end of the day, this is just an implementation detail. And at the end of the day, the most important thing is the use cases that we support. And observability is perhaps one of the most important, if not the most important use case that we have at ClickHouse. So I'd like to welcome Mike Shih, who is the creator of HyperDX and who leads observability at ClickHouse.
Thank you so much, Yuri. So we just heard so many awesome new announcements, the managed Postgres offering, the join optimizations, which I'm sure you will greatly appreciate when you go home and start doing those joins, as well as the continued evolution of ClickHouse Cloud. Now, how does observability fit into a database conference? The answer is that observability is one of the clearest examples of why the database engine matters. Our users, which we're really grateful to have some of these folks presenting later, have taught us the same reasons ClickHouse is so good for analytics is the reason that it is so good for observability as well. Observability data, if you think about it, has all the same characteristics that ClickHouse loves. Semi-structured, high velocity, high cardinality data. And when something breaks in production and you need to query your data, you need real-time access to your logs, metrics, traces, services, events, and much, much more. And we've already talked about how speed, scale, cost efficiency, and flexibility is so important for analytics. And of course, you can imagine the same exact principles apply to the observability use case as well. And observability is fundamentally an analytical workload. And as we've heard many times today, AI is putting even more pressure on that workload. Agents don't just ask one question at a time like I do when I'm doing an investigation. They explore across tons of dimensions, correlate more signals than any single user ever could, and iterate through data much faster than you could as well. And they need access to real telemetry, not just sample data or pre-rolled up data that throws away tons of context for the agent. And that only makes the underlying engine even more important. The ability to query and store high cardinality telemetry at scale helps engineers and agents get to the root cause faster than before. And of course, the expressiveness of SQL gives both, again, users and agents a more flexible way of asking those hard, complex questions as opposed to being locked into proprietary, lesser-known languages or predefined workflows. That is why ClickHouse is such a natural fit for observability. The same database engine characteristics that made it great for analytics only became even more important when it came to observability while bringing our agentic friends along for the ride. With that, I'd like to welcome Elijah McPherson, Engineering Director at Shopify, who will show how they're using ClickHouse to power observability at scale.
Awesome. Hello, good morning. I'm Elijah. I work at Shopify. I lead our storage systems org. Today I'm going to walk through a little bit of our journey at Shopify and how we use ClickHouse to monitor Shopify at scale. So, Shopify. To set the stage a bit, we run in 5 different continents, over 500 Kubernetes clusters, over 1.5 million pods at any point in time, many different programming languages, runtimes, databases, distributed systems, and we always need to be available. Commerce never sleeps, neither does Shopify. So this all culminates every year around BFCM, Black Friday, Cyber Monday. This is our Super Bowl. As you can see here, some kind of wild numbers, 90 petabytes of data across our infrastructure, 2.2 trillion requests served at the edge, and you can see our database volume here. A really important number to me is at peak load, we measure transactions per minute. We peak up to $5.1 million in transactions processed through Shopify. And so 1 minute of downtime can mean $5.1 million lost for our merchants. So observability is important for us. So taking a step back, I joined Shopify in 21. I came in essentially to build our own observability story. We were fragmented across many unnamed vendors for tracing, logs, errors, analytical queries, so to speak. And the cost was growing astronomically high, and we couldn't predict it. Another thing was this was disjointed. So our roadmap, we could not say, hey, we need this feature and correlate those across multiple vendors. So our answer was to build something for Shopify by Shopify. So we built Shopify Observe. That's what we call it internally. The idea here is that we can unify all of the signals of observability in one product, allow users to ask any questions, deploy with confidence, explore any kind of data that they need. And the story here, this was like multiple years, right? We started with metrics. Metrics was very, very difficult to do at scale. We moved from a very popular metric vendor that shall not be named, but you can think if they've probably been in some people's investor calls for cost. But we took on this challenge. We built this ourselves. We got massive cost reduction and wins. But then we started to look at traces and logs and exceptions, and we said, hey, like this is all just time series data and structured events. Tons of labels. How are we going to handle this? So first, we needed to spec out what were the requirements. At Shopify, again, I said it's pretty high scale. Over 50 million events a second is our steady state. We peak up to somewhere around over 100 and over 110 gigabytes a second in telemetry data. What's also important to us is durability. Many of our engineers really depend on this data being available. And they also want to query this data in under a minute. So we chose ClickHouse. We explored other options. ClickHouse was what won for us, primarily due to it being fast, being able to handle our load, and open source, right? Open source meant that we can contribute and understand the source code. So the story, to set like the lessons that we learned around this was durability being important meant that we could not just yeet and YOLO these logs over to ClickHouse. We had to build a pipeline for this. And that pipeline is essentially Kafka, where we buffer up that 110 gigabytes of data, and then we sync those big writes to ClickHouse. ClickHouse does not like tiny little small writes. You end up with too many parts, and we learned that lesson in production. It's important to think about schemas, and ClickHouse gave us this. So what we're showing here on this slide is our metadata. So in Observe, we have this product called Investigate. You can go in and do any kind of analytical query, but we have tons of events. That's all kinds of schemas. And what this allows us to do with materialization is materialize all the metadata on the fly and get sub-millisecond queries, actually around 1 to 2 millisecond autocomplete queries for our data. Materialization again for the win. We have many, many different events, and we want to correlate like things like trace ID, request ID, different background jobs. We actually materialize a lot of that data as well, and then we use that materialized view to scope down for our subquery. So if someone wants to say, show me all logs, all events, all traces for this job, we can do that. Our learning. So we've been running this platform in production for a couple of years. Production is wild. Production is where things break. Across all these schemas, we see many migrations, and we can't ever shut down ingestion. So a lot of this is we have to build a lot of our own tooling. So we have something we call blueprints internally. We do schema migrations on the fly. We have an operator that helps us scale. Another really important learning is like understanding the compute if you're going to run open source ClickHouse. Everything is a knob for us, and we use these knobs like CPU, different machine types, object storage to find savings and better performance. Specifically, one of our savings here is just taking a stream map and sorting it gave us better compression. So what's next for us? We are exploring different things. We're exploring SSDs, local SSDs on NVMe. We run on Google Cloud, so we're looking at trying things like C4A, as well as different column types. Now, like our ingestion path, I said somewhere around 110 gigabytes a second at peak load. That was last BFCM. These numbers tend to double for us. And so this is the hottest of the hot paths, where we've decided to rewrite our entire collection pipeline to be highly performant with no GC, and we're seeing massive wins already. I talked a little bit about like logs, traces, and exceptions. We actually run all of our profiling continuously, and we write those to ClickHouse as well. And then to sum all that up, we have now taken ClickHouse and moved it into our core product. We actually surface analytics powered through ClickHouse. Okay, so that's our story. We chose DIY. A big reason why we chose that was we just didn't have the time to, we didn't even have the ability to use ClickHouse Cloud. It wasn't there yet. And so we had to build these things ourselves. If I were to go back and look at the world today, I'm like, hey, do I really need to do this myself? Probably not. I think we would choose something like ClickHouse Cloud. They handle a lot of this for you. You can separate the ingest from query compute, and it actually turns out you don't need as many replicas of the data, and that saves money. So with that, that's our story, and I'll hand it back over to you all.
Thanks so much, Elijah. That trade-off he left off at, the trade-off between open source and managed ClickHouse products, is actually exactly where our next story picks up. I want to welcome to the stage Ben Shi, Senior Software Engineer at Zoox, to talk more about how Zoox moved their observability workload from open source ClickHouse to BYOC, improving scalability and efficiency as they continue to grow. Welcome, Ben.
Hi, everyone. I'm Bin Xi from Zoox. So we recently migrated the observability data from the self-management ClickHouse to the ClickHouse BYOC. So I'm going to share our story. Hopefully, you will learn something from it, since the principles applies, right, to migrate the data to ClickHouse Cloud. So first of all, about Zoox. So Zoox's vision is to build a safer, cleaner, more enjoyable future on the road. With a purpose-built autonomous robotaxi, we are live in San Francisco and Las Vegas, and coming soon in Austin and Miami. You can see the nice video here. So I wonder, like, how many of you are interested to try Zoox? Show your hands. That's quite a few. That's good, because at the last of the presentation, I will show you how do you get to ride Zoox. So today's ride, so the first station is observability at Zoox. I will talk about observability team's mission, the technical architecture, and also some of our challenges. And then we will move on why ClickHouse BYOC solve our problem, and some of the technical highlights about this migration. The last station is how to ride Zoox. So I will share, how to get to ride Zoox, like what I talked about. So observability team, the mission is to power Zoox with observability from software to rider experience. So our goal is to enable visibility across autonomous vehicle software, product, and rider experience through an intuitive, robust observability platform that drives data-driven decisions and operational excellence. However, we only have a very small team, and the data volume is huge and increasing fast. Autonomous driving has a very high bar of the safety. So we run very large simulation jobs, typically in the weekend, which is about 2x or 3x of the normal data volume. The data model we use both of the open telemetry and also the wide events. So open telemetry is like the standard, right? Then it comes to have issues when you have a very high cardinality data. And wide events are a bunch of fields and values. It is perfect, it prefers the short keywords over the long English sentences, which is logs. Wide events can include as much context as you have access to. So you can store full request context, high cardinality, and high dimensional data. So it is intended for dynamic exploration. For example, you start with a broad question and then narrowing down. So here's the kind of our data pipeline for events. So we collect data from SDK and agents, and we also have the softwares running on vehicles, sending us telemetry data as well. And then the data will land it in a centralized data pipeline where we'll kind of aggregate the data and also transform the data and then save the data to the ClickHouse data warehouse. And then for the users, we integrate the ClickHouse with Grafana, so users can create a dashboard, they can create alerts and also the SLOs for their services. And also they can run ad hoc queries in Grafana, and also they can use the superset as well to explore the data. We also have some internal tools that enable the MCP, so the users can use AI to explore data as well. So here's a kind of a short profile of our self-management ClickHouse. We have about 50K per second events. And we used to have a 48 nodes cluster, which is like use the replicate merge tree, the open source version. And that is 16 shards and 3 replicas. All of these are running in the NVMe storage, which is expensive. And also the total data volume we have is 16 terabytes compressed. The raw data is over 1 terabytes. And we have about 400 billion rows in total in those tables. So the challenge we have, Right, so as you can see, this is actually a real picture taken from Las Vegas. As you can see, as you can count, right, how many Zoox vehicles in the picture, right? You can see there are 4 of them. Can you imagine that, when you're driving in the traffic light and you can see, the left, right, all the Zoox vehicles, right? That is so cool and scary. Yeah. So as you can see, so now we are kind of expanding the fleet size, dramatically. As you can see, with the increase of the fleet size, we also see the data volume comes up. So one problem we used to have is to scaling our self-management cluster from 4 node to 60 node. We did it so aggressively that ended up with some corrupt statuses in the data warehouse and lead to some downtime. That is a kind of operational cost. And then on the other hand, for the dollar cost, right? Then as I mentioned, the data used to stay in the NVMe for the open source ClickHouse. So we really hope we can, offload the data to some like object storage, and also the compute. Also, computer resources also, takes money. So to meet the ever increasing data volume, we really a strategic decision is to find a data store system which is highly performant and also low cost. That's when the ClickHouse BYOC comes to the picture. So the reason why we choose the ClickHouse BYOC is one is for the operational excellence. It's very easy to scale, right? You can just log in the web console. It's just by a few clicks. You can scale it up or scale it out pretty easily. And then it automatically upgrade, so you kind of get the features for free. And then there are some pretty cool features, I want to highlight here. One is the compute-computer separation. As you know, we have the ingest, like the workload, but we also have the query. So we want to escalate those workloads so that one will not interrupt, interfere another one. Another feature is the scheduled scaling. So for in ClickHouse BYOC, it's not like ClickHouse Cloud that you can automatically scale. So we have to use some tricks. I think. Nicely, there will be some preview feature, private feature that we enabled, so we can just scale the system on a schedule. For instance, like as I mentioned, we have the large simulation jobs running in the weekend, so we just scale it up in advance and scale it down afterwards. That can also save cost. Another one is for the cost. We actually found out we can reduce the cost while migrating the ClickHouse from the open source to the BYOC. And then, as Zoox actually is an Amazon subsidiary, so we want to continue to use the good discount where we keep our infrastructure in our system. So then for the actual migration, right? Then the goals are one is to minimize the user disruption because the user observability is important. It has to be online 24/7, and the other one is to zero data loss. How we do it? There are a few steps we take. One is to provision the ClickHouse infrastructure. We actually set up kind of like a private link between our VPC and to the ClickHouse managed VPC. Secondly is to migrate the schemas and settings. And there are some of the, depending on the use case, right, you might already have some settings in your open source cluster, so you want to migrate to the ClickHouse Cloud. Usually the default setting is good, but for instance, like the asynchronizing insert, right, we used to have it in open source, we just migrated to the BYOC, but luckily the new versions ClickHouse, they have it enabled by default. And then to ingest the new data, as I mentioned, to minimize the user interruption, so we have create a new pipeline, ClickHouse writer, which write data to the ClickHouse BYOC. So we actually create a dedicated cluster called ingest cluster. And then, so this parallel pipeline will ingest the data from a certain cutoff time, let's say T0 time step, right? So all the data after that time will come into both of the system. And then how about the data before the T0, right? So we have to backfill the data. As you can see here, we have on the left side, we have the self-managed ClickHouse, And the right side is the BYOC. We also create another compute cluster called operations just for the migration. So in the self-managed ClickHouse, we have over 1,000 tables. And then those small tables are partitioned by months. And then for the large tables, we have over 10 billion rows for a table. Those tables are partitioned by day. So the steps we take is first to use the remote secure table function to move the data to a staging area, like staging tables. So the data will accumulate to the in the staging area. Once it's reached to the partition, let's say months, for the small tables, we then validate the data and then move the data to the final tables using the kind of auto table move partition. Here there are some technical details. One is, first one is the SQL to kind of use the remote secure table function to move data to the staging area. As you can see here, use the endpoint VPCE, which is actually the private endpoint. In this way, the data will not traverse to the internet. Rather, it's like from VPC to VPC. And then after that, we need to validate, right? Not only count the number of rows, but also do a hashing to see that actually, the data matches. Once that is validated, then the next step is to move the partition, using this SQL. I think the nice thing about the move partition is it kind of it avoids to create another, data duplicates, right? And then it's just it's similar like you create a, hard link in a file, in a file system. So the country can save costs as well. So for the production go live, right? Then, first of all, we think about the questions, like the metrics to watch when we, switch to the ClickHouse BYOC. There are a few metrics we watch. One is ingest throughput. We want to ensure that ingesting, going smoothly. There is no backlog. There is no lagging. And secondly is the query latency. Maybe choose the P99 query latency to see whether there are some degradation there. And then lastly is ClickHouse resource utilization. So how do we know those kind of metrics? Luckily, the ClickHouse have the built-in observability, help us to check those metrics. One way is to use the web console, the ClickHouse Cloud web console. It's easily that you can go into the monitoring. There are those dashboards and you can check. The other one is the Prometheus metrics. Actually, there are some endpoint that you can script those metrics, to your own, observability stack. This is actually set up here. As you can see, we set up multiple, data warehouses here for ingestion, for operations, and for query, and all of them share the same storage. Now that we are live, right, we have a solid foundation for the future, where we don't worry about the operational burdens and have manageable cost as we scale. What's next? So the future, right? Then, as I mentioned, there are two kind of data model. One is open telemetry, the other one is world event. But I think the line is blurry because ClickHouse have nice new features, like say the better support on the JSON and also the text index on the map data type. So I think the line is blurry. We are kind of ingesting more data, like open telemetry logs, a huge amount of logs, ingest 1 million per second, and also traces and metrics as well in our system. And also, on top of that, we are using the ClickStack as a user interface to enable the users to have a unified way to explore the data. So this afternoon, we will have a breakout session, so stay tuned for that ClickHouse breakout. Lastly, as I promised, right, I'll show you how to write Zoox. So in Las Vegas, right, because it's live, right, you can just download that app, right, then once maybe next time when you are in the airport, you can just try to hear Zoox. And then for San Francisco, you have to join the wait list because the demand is so huge. So we are kind of, creating the capacity. You need to join the wait list. And there is another way if you really hate the wait list. There is another shortcut, which is to join Zoox. Right? We are hiring, so you can check our website to see whether there are some interest in the open positions. That's all for today. Thank you.
Awesome. Thank you so much, Ben. Speaking of the future with ClickStack, I wanted to spend a few minutes on what's next for ClickStack and ClickHouse for observability. For anyone new to ClickStack, it's the ClickHouse's turnkey observability stack. It's open source at its core with first-class support for open telemetry, and it's designed to make observability fast to adopt on top of ClickHouse. The idea is simple. You should be able to go from zero to useful observability platform on ClickHouse within just minutes. I demoed this live on stage at Open House last year, but a lot has changed since we first announced ClickStack last year here. And what's changed the most, of course, is how AI is now moving into observability workflows. And today we're announcing new ClickStack features that make AI-assisted investigations even better on ClickHouse. The first of these is the ClickStack MCP server. As agents become more central to observability workflows, we want to give your agents the tools to become your best friend during your on-call rotations. With ClickStack MCP, we're giving agents high-leverage semantic tools that go beyond just doing searching or aggregation on ClickHouse, but able to do advanced things like surfacing log patterns, doing anomalous correlations, and likely causes of slow operations. These tools build already on the high-performance work that we've been working on ClickStack, so agents are always using the most optimized query paths for their queries and ensure that you're getting low latency results. This lets agents investigate real production issues using your data within ClickHouse with the added context of your code, runbooks, deployment history, and internal systems that you have access within your agents today already. And these more specialized and powerful tools give agents a leg up compared to having agents craft raw SQL on their own. In our internal evaluations, we've seen that agents with the ClickStack MCP score 70% higher on evals, require less than 25% fewer tool calls, and are 2.7 times more consistent in getting to the right answer at the end of their task. We built this MCP server as a purpose-built tool set for your agents, not just a generic API wrapper. And our goal with the ClickStack MCP is to build the investigative layer that your agents use to perform observability work on top of ClickHouse, wherever those agents run. And the ClickStack MCP is now publicly available in our open source distributions. And while the MCP server gives your agents the ability to access observability tools, to do incident investigation, the reality is a lot of that still requires human judgment. Engineers would like to inspect the evidence, change direction, validate queries, and decide what's a real conclusion versus what's hallucination. So when building our ClickStack in-app AI experience, we didn't want to just be another chat box, but a collaborative, interactive experience. So we built the ClickStack AI notebooks. It's a collaborative surface between users and agents. And every agent step is visible. You can see the query, inspect the results, edit, and rerun it. This allows engineers to verify the work before they act on the agent's answers. And because this is inside ClickStack, the workflow doesn't just stop at an AI-generated answer. You can drill into the actual data, logs, metrics, traces, tables, charts, what have you, and the agent could start the investigation, but you, as a user and engineer, can take over at any point. We also support branching because we know investigations aren't linear. You might have multiple hypotheses you want to pursue. And within the notebook, you can start with one and have the agent actually fork off to explore the other parallel hypotheses to make sure you're not just going down one single path. And we also know, of course, an incident investigation is a team sport. The investigation with AI notebooks are persistent and shareable. So the context doesn't get trapped in your own Claude code terminal. Teammates can open the notebook, see what was explored so far, edit, and keep going from there. And one last thing I want to talk about is that we're announcing the private preview of ClickStack Cloud. ClickStack Cloud is a new offering on ClickHouse Cloud that makes it the fastest way to get started with observability on ClickHouse. Getting started with ClickStack Cloud is as simple as pointing your existing OpenTelemetry instrumentation to our managed OpenTelemetry endpoint, and then logging into ClickHouse Cloud. Everything else from schema optimizations to scaling to a high availability ingestion pipeline will be taken care of for you in this offering, automating many of the things our users have had to build around ClickHouse in the past. This is just a brief preview of all the content we're looking to cover here at Open House. You could dive deeper into our latest product announcements, how other companies are leveraging ClickHouse for observability in our upcoming breakout sessions. At 1 p.m. in this room here, we'll go deeper into our latest product announcements, hear technical deep dives from LinkedIn and Zoox, as well as a technical talk on how we made ClickStack 72% faster over the past year on ClickHouse. And at 2:15 p.m. tomorrow, again here at the same room, we'll hear from our director of database reliability on how we built our own internal AI SRE workflows, followed by a fireside chat featuring DoorDash, RingCentral, and Traversal to talk about what they're seeing with AI adoption and observability and what's marketing hype and what's actually working for them in real life. Now with that, I'd love to hand it back to Yuri.
Thank you, Mike. So all of you might be wondering, it's a technology conference in San Francisco in 2026. We are an hour and 50 minutes into our keynote, and the words AI and agents have not been uttered once throughout the whole keynote. Well, fear not. I'd like to welcome Riyad Dehimen, who leads our AI initiatives at ClickHouse and who is going to tell us all about ClickHouse Agents.
Thanks, Yuri. Hi, everyone. So I'm Riyad, and I guess by now you all have that colleague who never shuts up about AI. Well, at ClickHouse, this guy is me. All right. So why I got excited about this space to start with? It's if we roll back to late 2024, I had this realization moment where I used Sonnet 3.5 back then, reasoning capabilities on top of data in ClickHouse, and I saw what it can produce. I mean, everyone has a model that kind of changed a bit his opinion on AI. For me, it was 3.5, and these properties that you've heard about already, probably with Tanya and with Mike and others, are the same that actually apply in the agentic world. You spin up a lot of agents, you can scale without breaking the bank and still maintaining an interactive experience. So beyond the theory, back then what we've done is we deployed our first agentic analytics use case internally. We deployed a platform, we hooked an MCP server on top of a ClickHouse service where we had our product analytics and our data warehouse data. And in about 2 months, more or less everyone at ClickHouse was using this platform versus our classic BI stack. We called it Dwayne. This is the last 4 months of Dwayne since January. This is the tokens usage. So you can see that we have days with 45 million tokens only on agentic analytics. Again, remember, this is not coding. So it's fairly token efficient. So 45 million is a lot of questions answered. And you can tell by the colors here, the days where we have a board meeting or some restitutions, I guess. But this internal experience was really good for us to understand what works, what doesn't work. And when we started, I said it was early days of MCP. Very few compelling MCP clients existed, even Cloud Desktop was the main one because they kind of set the standard there. I did some research and I stumbled upon a project called LibreChat. It's a multi-user chat interface with the no-code agents builder, really solid AI APIs, and a really solid MCP implementations. So we picked it, we used it. Most importantly, it's open source and has a thriving community behind it, used by very big names, downloaded so many times that it's battle-tested and hardened, and used by really good enterprise users that decided to productize their AI story on top of it. You've heard of FISA earlier today. A lot of US-based universities like Harvard and Stanford. Shopify runs thousands of these agents actually across their stack to power AI internally. So we deployed it, we used it, and one day, last summer, I called Danny, the creator of LibreChat, and asked him if he wants to productize this with us for our users, because we've been really happy with the way the use case unfolded and the way these customers reacted to it. And I'm happy to announce today that we're finally ready to ship ClickHouse Agents, which is our managed LibreChat service, now available in public beta to everyone. So just go to ClickHouse Cloud, run public agent, learn ClickHouse Agents. You don't need to do anything. It's completely turnkey, comes with its own model. It's a no-code agentic builder that can allow you to define your own agents internally, and with that, capture a bit of your institutional knowledge and share it with your colleagues. And it looks like this. So this, you can enter either from our SQL console, if you are already on ClickHouse Cloud. You can also go to ai.clickhouse.cloud and land into this managed service directly. I'm asking here about real estate data. This is not sped up. This is the real speed of a ClickHouse service delivering queries with LibreChat. And I can see that I have a data set here that contains UK property prices for 30 years or something. So by ClickHouse standard, it's not a big data set. It's just 31 million rows. But it's a good illustration of what you can do with an agent. You can supply it with more knowledge. So you can upload your skills. If you use agentic coding, you know what skills are. Simply like a free-form kind of text-based context management unit. We love it because it's so easy. And so easy to capture knowledge in that. So here I'm telling it about the data set, some reference queries, how to explore it. And I can build my no-code agent. It's just a form. Give it a name, a description, which is the system prompt. Give it some capabilities, like here, the ability to run code, to access some MCP tooling, whether it's the ClickHouse default MCP that ships with it, or others, like in this case, Notion. And I'm asking about the evolution of prices in London. I lived in London for like 5 years in the past, and that's a question actually I've been tracking for a while, so I'm personal interest here. I see that it loads the skill that I created, and it's running some queries. Again, real speed, so crunching data, producing aggregates. And it's a very token-efficient approach because the heavy data crunching happens on ClickHouse side. We just basically move the aggregates to the context window, and we can continue building hypotheses and explorations and produce basically an insight, the answer to my question. So now it's creating this HTML-based artifact for me to restitute the results, and I can have a good idea of what happened in London in the real estate area. It's pretty much flattened since COVID, apparently, and impacted differently different types of properties. But again, SQL-based agentic analytics is very powerful. It's not the whole story, though. There are some questions that SQL cannot answer easily when you go into like the predictive analysis area, when you want to do machine learning. So I'm asking for a forecast in this case, so statistical inference. And here, my agent is writing Python for me, not ClickHouse, because we shipped ClickHouse agents with a sandbox code interpreter that can run code for you. So think of it as like having on staff an analyst and a data scientist that can perform complex analysis for you. So this forecast is rather simple, I guess. The confidence bars are very open, but again, picture that with your own data sets, with your own seasonality effects, with your own correlation analysis, cross-referencing, and you have a very powerful time-to-insight machine available at your fingertips. We decided not to ship only the agentic harness. We decided to ship some of the lessons we learned by operating this use case and working with our early customers there. And the main lesson is actually the model is the most important variable in that story. That's where the reasoning, the intelligence come from. And as I said, we started on Sonnet 3.5. And since then, we've evaluated every model under the sun. We've run rigorous evals. We collected a lot of traces from our internal use case. And we still land on the Cloud family of models as kind of the best models for this job. That's why we decided to ship ClickHouse Agent with Cloud by default as your model provider. We also know that the context within an organization lives in multiple systems. We cannot ask you to fit all your context into scales or onto other constructs. We just need to connect to your systems. So MCP is our kind of trick there. We connect to Notion, Slack, Google, whatever. But some companies also picked an agentic platform. An example here is the Amazon Bedrock Agent Core platform. Think of it as like Lambdas for agents. So people already picked this platform, and we've partnered with Amazon Web Services to ship our ClickHouse Agent feature with a native integration to Agent Core. And I'm actually very happy today because I brought some friends from Amazon and Anthropic to say a word here on stage about how they perceived this announcement on their end. So we have Lucas from Anthropic and Ryan from Amazon.
Thank you very much, Riyadh and ClickHouse, for having me. My name is Lucas. I am a research product manager at Anthropic, and I just want to say I'm so excited to be here today. I feel like over the last year, Claude has become the go-to models for developers who want to write code. And I actually think the same thing is going to happen in the data analytics space. If you think about it, there's a lot of parallels between the two. Data analytics has mechanical scripting like SQL. It requires long and deep reasoning capabilities, and it's fundamentally iterative. And so that's why I think extending Claude's capabilities into analytics is an obvious next step, particularly when it's paired with the fastest real-time data analytics platform out there today. So I think ClickHouse is an outstanding surface to build on these capabilities with Claude. And I think that the powerful yet open and collaborative nature of it aligns really well with how we approach transparent and reliable AI systems as well. So I'm really, really excited to see what people build with it. And we have a fireside chat session later today. So excited to see folks there if you want to learn more. And once again, thank you to ClickHouse for having me. It's very exciting.
Awesome. And I'm Ryan Fox-Tyler, head of product for Agent Core on AWS. Want to also extend my excitement to be here and be part of this announcement. As we build around the agentic ecosystem with AWS, we built from the beginning knowing that it needed to be open. Open protocols, open frameworks, your choice of models, your choice of tools. And the partnership that we have with ClickHouse is really exemplifying that, right? You can have an agent on ClickHouse Agents, generate an insight, and then delegate that to an agent across your entire ecosystem to go find the root cause, address the issue, and return the result directly in ClickHouse Agents without you changing your context at all. Right, and we think there's not going to be one agent that rules them all. It's really going to be how that agent ecosystem comes together, and we're really excited to build that ecosystem with ClickHouse. Thank you.
Thank you so much to Anthropic and Amazon for joining us today. Again, I'm very excited. Even though ClickHouse Agent is a big milestone, it's actually just one box in the bigger picture. This one on the top right, of what we believe is an open platform for AI workloads. We have many components. We have a data layer, a connectivity layer, agentic layer, observability, LLM engineering, etc. Again, I can talk about that for an hour. In fact, I'll do it this afternoon. I'll talk about it for an hour and a half during the AI breakout session with our friends from Anthropic, Amazon Web Services. We'll also hear from our customers, Fetch Rewards and Tekion, how they adopted agentic analytics at their scale. And in this session, it's also an opportunity for everyone to ask your question. We'll present our thesis there of a composable, open platform for AI workloads. And thank you very much for having me. With that, the same way we work with Anthropic and Amazon, we have actually numerous other partners that we want to introduce. And my friends here, Alex and Abby, will talk about that.
Thanks, Riyadh. It's amazing to see the progress we made with agents. I was literally just using them backstage to create some more slides for my next talk. And so my name is Alex Francor. I lead our product integration story here at ClickHouse, and I'm joined on the stage with Abhinav Mela, who's our VP of Partners and Alliances here at ClickHouse. And we're going to give a quick update on our community and ecosystem. So Alexey shared earlier that we are celebrating 10 years of open source ClickHouse. This is an amazing feat, especially with the growth and adoption that ClickHouse has seen over the years. And I believe we're building generational infrastructure. And as much as I would love to give credit for the success of ClickHouse to Alexey and the brilliant team of engineers who are continually optimizing ClickHouse on a daily, if not hourly basis, I don't think we can. ClickHouse wasn't built in a vacuum. Open source technology is really only as strong as the ecosystem and community supporting it. And we know that. It's in our bones. Take a look at the systems.contributors table just to see how much we value the external contributions. And while we're fortunate enough to have some of the best engineers on the planet working on ClickHouse and the native integration points for ClickPipes, our language clients, our open source connectors, and we're partnering and integrating with some of the most innovative companies in the world, we wouldn't be where we are today without the support, trust, and innovation we've seen from our community. So on behalf of ClickHouse, I'd like to thank our community for all of the external contributions they made to our ecosystem over the years. And there's been a lot. You saw the contributions that Alexey had shared, and by my count, we have at least over 200 integrations out there in the wild. And our list of supported integrations and managed services continues to grow every single quarter. And so we built a pretty rich and healthy ecosystem across a variety of different categories over the years, and with integrations covering data ingestion, AI, ML, transformation, BI and analytics, orchestration, security, data governance, the list goes on. And this ecosystem is growing more and more every day. More recently, we're seeing a dramatic expansion of integrations with the introduction of our MCP server and our ClickHouse skills. We now have native integrations being built on these tools regularly, from AI coding agents like Cursor, to AI assistants like Claude, to productivity tools like Notion, and agentic platforms like Anti-Gravity. And so beyond this, we're also seeing a new trend emerging. The adoption of our MCP server has exploded dramatically. That's a real chart in the background there. And we're seeing more and more bespoke and unique integration points into ClickHouse. Our community is built around partnerships. And so we're investing in tighter integration points with a select number of partners. And tomorrow will be filled with breakouts going deep on better together stories and a flurry of announcements. We'll have exciting talks from AWS, GCP, Microsoft, Azure, DBT, Fivetran, Hex, Sigma, Vercel, and more. And be sure to check them out to learn a bit more about how our ecosystem is evolving. And with that, I'll pass it to Abhinav to share a bit more about how we're investing more in our community and partners.
Great. Thanks, Alex. So before I move into how we're investing into the partnerships, I want to take a step back and call out, okay, why are we doing that in the first place? So speed is in our DNA. Speed is the reason why you guys are in this room, because you appreciate ClickHouse for its speed and performance. But database is only half of the equation. When you're getting into production, you want to integrate ClickHouse with your tool set, and you need the expertise in terms of migrations, and you need the right procurement channels, and those things can slow you down. So we thought to ourselves, what can we do to make sure that you don't slow down? With that in mind, I introduce Housemates, the ClickHouse partner community and program. This is exactly what you need to build faster and build with confidence when you're building with ClickHouse. So let me dive deeper into it. What does that really mean for our customers? First, integrations. So Alex called out the pre-built integrations. We're working with leading ISVs across the globe to deliver pre-built integrations, production ready, validated by us, that you can confidently take into production. Second, expertise. We're working with some of the leading SI companies and services system integrators across the world, in each and every region across 6 continents, so that wherever you need expertise, whether it's related to complex migrations or building your next agent, you have those people right on the ground helping you build those and getting into production. Third, procurement. We're extending our reseller network so that whether you want to buy through marketplace or a reseller for your choice, you can do so without any friction. So I'm proud to say that we're announcing the initial cohort of over 60 partners, more than 25 ISVs, where we're working closely with them to launch integrations. Some of them are already in live, which you can leverage from today. And over 35 services and channel partners whom you can rely on a service delivery capability when you want to build anything. Whether you're in Indonesia, whether you're in Japan, whether you're in Saudi Arabia, or here in Bay Area, we have people on the ground to help you get to production. And this slide isn't just like we worked overnight to put some logos out there. We worked over the last 6 months with the services partners to train them on ClickHouse. They got certified on ClickHouse. They delivered projects, and that's why we can stand behind it. So when you're working with the housemate, you can be confident about the delivery capability. Now for the partners in the room, Housemates is your next revenue engine. We invested into your growth, and how we're delivering is around 4 pillars. Go-to-market, so co-selling, co-marketing, joint campaigns, account planning, account mapping. We'll bring you into our pipeline, and our expectation is that you do the same. Second, enablement. So we've launched specialized tracks for our partners so that they're as smart as our engineers, and they can deliver with confidence. There's specialized labs, training tracks, free certifications available to partners. Third, incentives. Incentives for partners who would refer deals to us, as well as incentive for our resellers partners, and these are aggressive in nature. So that when we're making money, our partners make money. And fourth, co-innovation. Partners have access to our solution architects, our product teams, engineering teams, so whether you're building a solution or an integration, you have the right best practices and guidance from us, and you can deliver those integrations and solutions. On top of that, we're giving you ClickHouse credits so that you can build those run POCs, build those integrations, build those solutions without worrying about the costs. The partner program is structured around 3 tiers, and the journey starts with Ignite. Ignite is the foundational tier. This is where, for services partners, this is where you build your readiness, enable your teams, and deliver those lighthouse projects. For tech partners, it's more about building the first integration and driving early adoption. Once you build that foundation, you move to Accelerate. This is the second tier. This is where momentum takes over. So this is where we lean in and give you more go-to-market support, more co-innovation support, more incentives, and so on. And Prime, that's the highest tier reserved for the partners who are like really embedded into the partnership. They have the biggest ambitions of working with us, and they're making huge investments into the partnership. That's where scale takes over, and we're operating with you at scale. With that, Housemates is live today. So for customers, if you're looking for a housemate for your next project, scan the QR code on the left side, and for partners who want to be enrolled into Housemates, scan the QR code on the right side or find me after this keynote. We can discuss. So with that, welcome to Open House. Welcome to Housemates.